In this video, I'm going to explain how to derive the equation for single standard addition. So we have two flasks here, and each of the flasks have the volume of V0, and the concentration will be Ca. And in only one of them, we add a standard volume of VSCD for volume of standard, and this volume will have a concentration called CSTD. After that, we're going to dilute it into the final volume VF. So these two flasks will have the same final volume. So how we can derive this equation? We can calculate the concentration of the analyte in the flask 1, and this will be flask 2. So the concentration of the analyte in flask 1 will be Ca times V0 over Vf. And in the second flask, it will be Ca multiplied by V0 divided by Vf. This is a dilution factor, so I'll write that down as dilution factor plus the concentration of the standard CSTD times VSTD over Vf. So this is also a dilution factor. Then we know this equation where the signal is equal to the constant times the concentration. Then it leaves us to the signal of the flask 1 will be the Ka multiplied by the C, and the C in this case will be this equation. So Ca times V0 over Vf. Similarly, in the second flask, the signal will be Ka. Remember, we have the same Ka in both flasks, multiplied by this guy over here. So I'm just going to call the first flask as signal sample and the second flask as signal spike. So we're going to rearrange these two equations in terms of Ka. Then we have Ka is equal to S sample divided by this one. And similarly here, Ka is equal to S spike divided by this guy over here. Because these two are same Ka, we can equate this formula with this one. So what does that brings to us? We have S sample over this is equal to S spike over this. So I'm just gonna move this into the denominator, and this denominator will be moved up to the numerator. Then it leaves us to the equation S sample over S spike is equal to Ca VO divided by Vf, whole thing divided by Ca VO Vf plus CSTD times V standard over VF. And we can, multiply both the numerator and the denominator by VF, because that's the same as multiplying by 1. But what does that do is we can cancel this VF out and VF out here. Then we have the equation S sample over S spike is equal to CAVO divided by CAVO plus CSTD VSTD, which is the same as the formula given here. The most important part in this section is the addition of the standard. And you should know that the amount of standard added should be a very small amount. Why does it have to be small? That's because we want to make sure that the Ka is the same in both flasks. Remember, if this is not same, then we cannot equate this equation with this equation. So this is very important that the Ka is the same. And in order to make the Ka the same, you need to make sure that the standard added is very small amount. So I hope you enjoyed that video, and I will come back with an example in the next video. Thanks for watching.